we often take gravity for granted. It's the force that keeps our feet on the ground and makes things fall when we drop them. But have you ever wondered how we found out how gravity works? In this video, we'll explore how one of the world's most influential scientists, Sir Isaac Newton, discovered gravity. 1. The falling apple. The story of Newton and gravity starts with a falling apple. According to Newton's friend, William Newton was sitting under an apple tree one day around 1665 to 1666 when he saw an apple fall straight down from the tree. At that time, Cambridge University was closed due to the Great Plague, so Newton was just kicking around, thinking about stuff. And he started wondering why the apple fell straight down instead of falling sideways or up or any other direction. He thought to himself, if the apple falls down when released, then what makes it fall straight down? Maybe there's something special about the ground underneath this tree. But then he thought, no, why should there be something special about that ground? That's when he had his famous insight. He realized that the same force that pulled the apple towards the ground could be the same force keeping the moon in orbit around the Earth. 2. Connecting Earth and space. Before Newton, scientists like Galileo studied how objects fall, and Johannes Kepler described how planets move through space, but no one had connected the two ideas. Newton was the first to realize that the same force could be responsible for both falling apples and the motion of the planets. He called this force gravity. 3. Mathematical breakthrough. To quantify this force, Newton came up with an inverse square law. His idea was that the force of gravity gets weaker the farther away you are from the source. Like if you were twice as far away from the Earth's gravity would be 4 times weaker on you. Mathematically, he wrote it as F varies as 1 over r squared, or F equals gm1 m2 over r squared, where F is the force of gravity, r is the distance between two objects, and g is a constant. To test this, Newton compared the acceleration of a falling apple near the surface of the Earth with the acceleration of the moon. He knew the acceleration of the apple was about 9.8 meters per second squared, and using what was known about the moon's orbit, he calculated its acceleration to be the same, 9.8 meters per second squared. This showed that the same force that pulls things down on Earth is what keeps the moon in orbit around the Earth. In other words, gravity, for Newton's law of universal gravitation. In 1687, Newton published his law of universal gravitation, which basically says that every object in the universe attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the distance between their centers. He wrote it as F equals gm1 m2 over r squared, where F is the gravitational force, g is the gravitational constant. m1 and m2 are the masses of the two objects, and r is the distance between their centers. With this, he explained not only why planets orbit the sun in a path described by Kepler's laws, but also why tides happen on Earth due to the moon's gravity pulling on Earth, as oceans, and why comets and stars move through space and everything else. 5. Legacy Newton. Gravity stayed the most accurate description of the universe for more than 200 years, until Einstein came along. Einstein's theory of general relativity expanded our understanding of gravity, especially in extreme cases like black holes and on cosmic scales. However, Newton's laws still hold true for most everyday motion, like spacecraft traveling through the solar system, apples falling from trees, and us walking down the street. So thanks, Isaac. Do you find this interesting? Let me know in the comments. And don't forget to subscribe for more videos like this. See ya!